So picking back up where we left off, this next one I want you to find the measure of arc AB, this piece right here. Well, I have to start with what I know, and that's that this angle, this inscribed angle, is 20. So I'm going to work my way out and then see if I can work my way over. So remember, if we go out of the circle, we're going to multiply by 2. So that would make the measure of this arc right here. So there's my angle. I'm going out to that arc. 20 times 2 would make that arc 40. And then we have to think, well, how would we find this piece? Well, half of a circle, I see half of a circle. Think, what does half of a circle add up to? Well, that'd be 180. So then 180 minus 40 would tell me this missing part right there. So 180 minus 40 would make the measure of that arc 140 degrees. So this last one got a little bit more complicated because it wants JLM, that angle right here. So I'm going to go ahead and trace it. Well, that angle opens up to this arc right here. So I need to find this arc. Well, if this piece is 88, if that angle is 80, I'm going to start with that. Remember that central angles are the same. So if this is 88, then central angle is the same. That means that that arc is 88. Well, then I'm noticing, once again, I have another semicircle. So think about it. If this piece is 88, and I have a semicircle which adds up to 180, well, I can find this yellow arc right here because the central angle 88 is the same as 88. 180 minus 88 makes that piece 92. And if I know that arc, now I can find that inscribed angle. So just be thinking, like, how do we find the inscribed angle if we have the arc? So what do we do if we're going in? Well, if we're going in, we're going to divide by 2. So 92 divided by 2 would make the measure of that angle 46 degrees. And those are some of our more complicated inscribed angle problems. Now, sometimes you'll have actual equations, so you could have to double something. So like we could know that the inscribed angle is x plus 1. So like, for example, if this piece is x plus 1 and this piece is 45. Well, I know that 2 going out times 2, so 2 times x plus 1 would equal 45. So sometimes we have equations as well. So taking a look, I have 2 equations here. I'm going to go ahead and trace these. So I know that this one right here is 2x plus 1, and it opens up to that arc right there. And then I have this other angle right here is 4x minus 3, and that opens up to that arc right there. Well, this one, notice that they're going to the same arc. We did one like this earlier. Remember, if their 2 angles are going to the same arc, well, one was 28, the other one was 28. So if the 2 angles are going to go to the same arc, that means that they're going to be exactly the same. So to set up this problem, I could just do part equals part. So 2x plus 11 equals 4x minus 3, or 4x minus 3 equals 2x plus 11. And once you put that letter on the left and solve, which I'm going to cut out some steps, but if you solve it correctly, you should get that x is 7. So those are your inscribed angles. So pretty much if you're going out times 2, if you're going in, divide by 2, but if they go to the same arc, then they're going to be the same. So let's take a look at a few of our other options that we talked about on this formula chart. Because we don't just have inscribed angles. We also have wannabes, we have crisscrosses, and we have outsiders. So taking a look, I need to figure out what I have and then what's the rule from there. So if I take a look at this one, I have a chord and then I have a tangent. It's not quite an inscribed angle, but it's like half in, half out. This would be an example of a wannabe. And remember that that's not an actual geometry term. That's just a little tip or trick that I use to kind of keep everything straight. So that would be a wannabe. So remember that wannabes follow the same exact rule as inscribed angles. So if this is 117 degrees and I'm going out, well, remember if we go out, we're just going to multiply by 2. So if I go out, I'm going to multiply by 2, and that would tell me this arc right here. So 117 times 2, I'm going to give you a minute to do that if you need to. That would make the measure of arc 1 234. So this piece right here would be 234. Okay, well, think about it. What if I asked you, so I know that this piece is 234 because I did 117 times 2 going out. But what if I wanted to know the rest of it? What if I wanted to know the measure of arc 2? Well, what do we know about a full circle? I kind of have to look at the whole picture. If I have a full circle, the measure of that would be 360 degrees. So if I know that this piece is 234, well, I can just do 360 minus 234, and that's going to tell me that part right there. So 360 minus 234 would make the measure of arc 2 just 126. So sometimes these problems look a little bit more complicated. I might have to use other things that I know, but it definitely does help to kind of figure out, what do I have? Do I have a wannabe? Do I have a crisscross? Do I have an outsider? Do I have an inscribed angle? And then kind of go from there. So taking a look at this next one, I see the crisscross. So this is a crisscross. So I have those right there, and then they're attached to those arcs. Like each chord, if I connect those chords, it's this arc and that arc right there. So they kind of just like line up. So if I go back and I look at the formula chart, the crisscross rule said to add the arcs and divide it by 2, and that's going to tell me this angle right here. It doesn't tell me angle 1. Angle 1 would go with those arcs, but it kind of lines up just perfectly. So if I add these arcs and divide by 2, it's going to tell me that angle right in there. So that's what I need to do. So I'm going to go ahead and add these arcs. So 115 plus 97 is 212, and then I'm going to divide that by 2. That's what the formula said to do. Add the arcs, divide by 2. So then the measure of angle 2 would be 106 degrees. That's it. Add the arcs, divide by 2 if you see a crisscross. Now, if we asked you for this angle right here, that goes way, way back. Remember that if they're next to each other, they add up to 180. So angle 2 is 106. I found that by adding the arcs and dividing by 2, but I could find angle 1 by just subtracting from 180, which would be 74 degrees. So jumping around a little bit, I want to jump and look at this one right here. So asking ourselves, is it an inscribed angle? Is it on the edge of the circle? It's not quite on the edge of the circle. So then it's not a crisscross. I could tell it's not a crisscross. It's not an inscribed angle. It's not a wannabe. It's not on the edge of the circle, so it's not an inscribed wannabe. This would be an example of an outsider. So the outsider, as we see, it kind of takes it, and then we have these little arcs that it cuts the circle. So like, I don't want the outside parts, but like I can kind of see that to get that I have those arcs right there. So let's go back and look at the outsider rule. And the outsider rule is to subtract the arcs and then divide by 2. So going back, I'm going to subtract the arcs. It kind of, you're working your way like out. So I'm going to do 92 minus 43. So 92 minus 43, the bigger number minus the smaller number, is 49. And then I'm going to divide by 2 to tell me the measure of angle 1 on the outside. So 49, subtract your arcs, divide by 2. So 92 minus 43 gives me 49. Divided by 2 would make that angle 24.5. That's it. So it's a little bit easier once we know what it is. Like, is it an inscribed angle? Is it a wannabe? What is it? So let's go back and take a look at this kind of weird looking one right here. It's not a crisscross. If it were an inscribed angle, it would be fully inside the circle. And if it were a wannabe, then it would be half in and half out, which this is neither of those. This is an outsider. So outsiders can look very different. Remember we said we could have like a secant and a secant, but we could have a tangent and a tangent. So this was an outsider with a secant and a secant. This is also an outsider, which is going to be the same rules. What makes this one a little bit different is that it's completely outside. So that would be one arc, because my rule with outsiders is subtract the arcs. But the problem is that I don't know the other arc. So first I'm going to need to find the measure of arc 1 before I can subtract the arcs and go from there. Well, sometimes you have to look at the big picture. So if you have a full circle, that's 360. And I know that this piece is 270. So to find the measure of arc 1, I just need to take that away from 360. So 360 minus 270 would make that piece right there 90 degrees. So the measure of arc 1 would be 90 degrees. Now, how does that help me find the outsider? Because I need to subtract those two numbers and divide by 2 to get this outsider, to get angle 2. So to find the measure of angle 2, I'm going to subtract my arcs. So the bigger number, 270 minus 90, So 270 minus 90 is 180, and then divide it by 2. So the measure of angle 2 is going to be 90 degrees. It was just kind of a fluke that they were the same number. So some of these problems, it's a little bit difficult to tell what they are, and then we're going to have some extra steps. Now, before we do anything else, I want you to go through, before we jump in with the next video, I want you to tell me, what are these? Remember, you've got 4 options. It's either going to be an inscribed angle, a wannabe, a crisscross, or an outsider. So taking a look at your chart, go ahead and use your chart and see if you can figure out what those next ones are, and then we'll talk about how to use those formulas in the next video. See you in a